Training convolutional neural networks is an essential aspect of building machine learning models for object detection and classification. But training process of CNN require more time, cost and energy when it comes to frequent platforms like CPU, which are supported by the frameworks like TensorFlow, PyTorch or CAF. Therefore, it is important to have an efficient training process which require low latency, cost and energy. These requirements can be achieved with high-end GPUs provided by cloud computing platforms like Azure, AWS, Google Cloud Platform, Colab, Kaggle and Jupyter, etc., which are highly expensive with varying cost. But there isn't any available embedded system for edge computing that is capable of efficient training of CNN. Therefore, we were supervised to build up an edge computing device capable of training. And as the initial approach, we were able to create a hardware accelerator using Ultra 96 V1 FPGA development board, and the architecture was tested using YOLO Lite as the proof of concept. Efficient training of CNN models can be achieved using high-end GPUs or cloud platforms, which are highly expensive forms of training. Therefore, we were supervised to build up an edge computing device capable of training CNN having these objectives. Higher performance with a minimum of 1 order of magnitude of speed comparable to Darkflow, which is a training and inferencing TensorFlow codebase built for YOLO architectures, running on CPU. Low cost and low power consumption. This is the overview of the hardware architecture. Pre-processed images, annotated true values and initial weights will be transmitted to FPGA via UART from PC. Then it will be stored in DRAM and be received from PS in order to send it to the PL for further processing. Iteratively, PS and PL will do the computational processing, then updated weights will be sent back to the PC through UART or USB. Finally, we take timing results for one iteration of the training process on Training Pascal VOC 2012 dataset. Here are the results of computational timing comparison for CPU, GPU, TPU and FPGA. We have used Google Colab free version GPUs and TPUs for our calculations. GPU and TPU are 4 times faster than CPU and FPGA is 23 times faster than CPU. Here we used Intel Core i7-5500U CPU at 2.4 GHz speed to get the CPU time. To get the TPU and GPU timing values, we used TPU version 2 with 8 cores and NVIDIA K80 with 2 cores respectively in the Google Colab free version. Ultra 96 V1 FPGA was used to take FPGA timing values. In the modern world, it is important to have an efficient training process which require low latency, cost and energy. Currently, these requirements can be achieved with only high-end GPUs provided by cloud-based platforms as mentioned previously. Therefore, creating a hardware accelerator for training CNN models would be highly advantageous to researchers and general public who are interested in machine learning, to carry out their CNN training process efficiently and securely.